Chapter 8 Discrete Random Variables. In this tutorial, we will learn how to use the probability distribution to find probability of a random variable describing a given relation. Look at this description. Finding the probability that x is less than a particular value, greater than a particular value, or lies between two values. So, probability of x less than a, or probability of x greater than b, or probability of x when it lies between two values which are a and b. Look at this example. A discrete random variable x has the following probability distribution. The values of x are from 1 to 6, and we have the corresponding probability for each value. We need to find the below. Find probability of x between 1 and 5, between 2 and 4, and we have inequality, between 3 and 6, and finally x less than 3. Part A, we need to find the probability when x is between 1 and 5. We will do a recap about the concept of inequalities. The x is greater than 1 but not equal to 1. Here we don't have equality. The value greater than 1 is 2. Also, the x is smaller than 5. The value less than 5 is 4. 5 is not included because we do not have equality. So we want the values that are 2 and greater than 2, also 4 and less than 4. So we take the values 2, 3, and 4 in order to find the probability. We cannot take 1 or 5. Probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4. These satisfy the relation that x is bounded between 1 and 5. The corresponding probability for x equals to 2 is 0.2, plus probability for x equals to 3 is 0.3, plus probability for x equals to 4 is 0.25. The total is 0.75. So, the probability when x is bounded between 1 and 5 equals to 0.75. Now for part B, find the value of x when it is greater than or equal to 2 and less than or equal to 4. First, we look at the boundary. X greater than or equal to 2. So here we have equality. We start from 2 and we look at the value that is greater than 2. At the same time, we want less than or equal to 4. So we take 4 and we look at the value that is less than 4. The boundaries are 2, 3, and 4. Here we took the same values as part A. The only difference is that here we have equality. Remember that when we have equality, we take this number and what is greater than it until we reach number 4. And we also take it and the numbers below it. The answer is probability when x is 2 plus probability when x is 3 plus probability when x is 4. The final answer is 0.75. So, the probability when x is bounded between 2 and 4 and it is inclusive equals to 0.75. Part C, probability of x bounded between x greater than 3 and less than or equal to 6. Notice that for the 3 we don't have equality, so we take the number that is greater than 3, which is 4. 6 has equality, so we take it and we take the number smaller than it. The values are 4, 5, 6. So probability of x equals to 4 plus probability of x equals to 5 plus probability of x equals to 6. Now we read the corresponding probabilities. We have 0.25 plus 0.1 plus 0.05. The answer is 0.4. Therefore, probability for x bounded between 3 and 6, the 6 is inclusive, equals to 0.4. Part D, probability for x less than 3. Therefore, there is no equality. So the 3 is not included. So we take the 2 and 1. So we write the following. Probability of x when it is equal to 1 plus probability of x when it is equal to 2. Now we read the probability. We have 0.1 plus 0.2. The answer is 0.3. Therefore, probability of x less than 3 is 0.3. By using the probability distribution, we were able to define the value of the random variable that satisfies a certain relation.